Hello friends, welcome to today's video. One of our members requested that I do a video on determination of calcium oxide in lime used in sugar industry. I hope this video will benefit him and other people who wish to know more about analysis done in sugar industry. Lime is majorly used in sugar industry to clarify juice extracted from sugarcane. Lime has a compound called calcium oxide, and the functions of this calcium oxide are: number 1, to boost pH of cane juice from 5.0 to 8.2. The second function of calcium oxide is to react with impurities like acids, suspended solids, and coloring pigments to form precipitates that can be easily removed from juice. For more information, kindly watch my video on sugar technology, video 3, juice treatment. Slurry prepared by mixing lime and hot water is generally referred to as milk of lime. Lime cannot be effective in juice treatment if calcium oxide in it is not fully dissolved in water. If the percentage of calcium oxide in prepared milk of lime is low, a lot of milk of lime will be used to boost the pH of juice, leading to chemical wastage and high cost of production. To minimize wastage of lime, the company has to do the following. Number 1, mix lime with hot water because calcium oxide is slightly soluble in cold water but soluble in hot water. Number 2, stir the prepared milk of lime for around 5 hours to allow more calcium oxide to dissolve. And lastly, laboratory staff must analyze every lime brought in the factory to determine if it has the recommended calcium oxide content. In this video, we are going to see how calcium oxide in lime can be analyzed. This analysis are: number 1, we have sample, and our sample will be lime. Next, you have sugar. Next, reagents. Under reagents, we need phenolphthalein indicator and sulfuric acid of normality 1/2.8. Next, we need distilled water. Next, 200 ml volumetric flasks. Next, we need 1 250 ml volumetric flask. Next, we need 1 500 ml volumetric flask. Next, we need weighing scale. Next, we need beakers. Next, spatulas. Next, water bath. Next, conical flask. Next, burette and measuring cylinder. Let's see how we can prepare 500 ml of sulfuric acid whose concentration is 1/2.8 normality. Only concentrated sulfuric acid is purchased in laboratory, so you will need to dilute the concentrated sulfuric acid with distilled water to get the solution of required concentration. You have to calculate the volume of concentrated sulfuric acid and volume of water needed to achieve the required normality. The following formula is used to calculate the volume of corn sulfuric acid that is needed to prepare 1/2.8 normality sulfuric acid solution. N1 times V1 is equals to N2 times V2, whereby N1 is normality of corn sulfuric acid and the normality of corn sulfuric acid is 36.8 N. V1 is the volume of corn sulfuric acid. N2 is normality of required solution. So our solution, the concentration of our solution is 1/2.8 normality. V2 is volume of required solution. So we need 500 ml of this solution. So our V2 is 500 ml. So we'll take 36.8 times V1 is equals to 1/2.8 times 500. So you'll get that, you'll see that V1 is equals to 4.852 ml. That means for us to get 500 ml of sulfuric acid whose concentration is 1/2.8 N, we will need 4.852 ml of corn sulfuric acid. Since sulfuric acid is a dangerous chemical, you have to prepare it carefully. First, put 300 ml of distilled water in 500 ml volumetric flask and add slowly 4.85 of corn sulfuric acid, then top up to the mark with distilled water. Below is the procedure for analyzing calcium oxide in lime. Number 1, collect a sample from the bags brought. Next, weigh 5 grams of lime sample and dissolve in 60 ml of distilled water. Next, weigh 50 grams of sugar and dissolve in 70 ml of distilled water. Next, Heat both milk of lime and sugar solution prepared in hot water bath while shaking to 70 degrees Celsius. Remember, calcium oxide is slightly soluble in cold water but soluble in hot water. That's why it must be heated in hot water bath. Next, mix the heated milk of lime and sugar solution in 250 ml volumetric flask. Remember, the reason why we mix lime and sugar is that sugar enhances the solubility of calcium oxide in water. Next, shake the mixture for 30 minutes. After mixing for 30 minutes, top up the content in the volumetric flask with distilled water to the mark. Filter the content through filter paper. Collect the filtrate. Pipette 25 ml of the filtrate to a Concord flask and add 3 drops of phenolphthalein indicator. Put the sulfuric acid solution prepared in burette and mount it on the stand. Titrate the filtrate that is in Concord flask against 1/2.8 normality sulfuric acid that is in the burette until color changes from pink to colorless. Record the titer value. Calcium oxide is a base and reacts with sulfuric acid to form calcium sulfate, which is a salt, and water. Phenolphthalein indicator is pink in basic solution and colorless in neutral solution. That's why the color changed from pink to colorless. Amount of sulfuric acid added to solution in the Concord flask is used to calculate the calcium content in that solution. So the calcium content is equals to titer value times 2. For example, if our titer value was 34, so the calcium oxide content will be 34 times 2, which is equals to 68. Lime used should be fresh, well burned, and properly packed to avoid exposure to atmosphere, because poorly handled lime will have less calcium oxide content. Lime that has calcium content of above 60 is okay and is accepted by the factory, but that one which has below 60 is rejected.